Hi, welcome to another screencast. Today we'll be talking about metamorphic rocks. Now remember, the word metamorph simply means to change between, or it can mean to change form or change shape. So what we're talking about is a pre-existing rock, like a sedimentary, metamorphic, or an igneous rock that gets changed in some way into a metamorphic rock. So how does this happen? Well, first off, we have heat. Heat is very important in this process because, well, it can help with the reorganization of crystals. It can also help new crystals grow within rocks that, well, didn't ordinarily have them. This heat comes from the interior of the earth. Remember, it gets hotter as we go down there, and from that magma that rises up from the interior, it's going to apply heat to the rocks that it touches. Then pressure is required. Well, that pressure can come from the weight of rocks that lie above, or it can come from the collision of two crustal plates, and that rising magma can apply pressures to the rocks that are above it. Then we have chemically active fluids. Most of the time, those chemically active fluids are very, very hot water. And I'll show you a couple of environments where we see that. So here on the left-hand side, we can see where the pressure comes from. You'll notice that we have a lot of layers of sedimentary rock, and the layers at the very bottom of those, that sequence of layers is going to feel all the weight of those rocks above. It's also going to be a lot warmer down in this area, and so there's going to be the heat that's present as well. Then the bottom, what we have is a crustal plate on the right. We have a crustal plate on the left. These two crustal plates are colliding to create these huge mountain ranges, and look at these rock layers in the middle. They're all twisted and contorted, and it looks something like this with these stacks of papers. If I push from both sides, these stacks of papers get bent and twisted, and that creates a lot of pressure. This is the kind of thing that's going on within the core of the Himalaya Mountains. Then over here to the right, what we have are a couple of pictures of Yellowstone National Park. Now this is an area that has very hot water. It's known for its geysers, its hot springs like you see in the bottom right, and this is an area that has a lot of chemically active fluids, so we have some of that metamorphism going on. Now it's important to remember a few things as far as the causes of metamorphism. Number one, the rocks must remain solid. Remember, if the rocks melt, number two, it will become magma or lava, and the only rock we can get from that is an igneous rock. And then the third thing to remember is that during metamorphism, the minerals may recrystallize and get bigger, or new crystals may pop up, but it all happens while that while that rock remains solid. Now, metamorphic textures. Remember, we typically lump rocks into a couple of different categories. With igneous rocks, we have intrusive and extrusive. Sedimentary rocks, we have chemical and clastic sedimentary rocks. Well, for metamorphic rocks, we have foliated and non-foliated textures. Now, wavy layers are a characteristic of foliated rocks. I'm going to show you an example of one of these. It may be a little difficult to see because of the camera, but this has some layers on the side. This one may be a little bit easier to identify. This is called phyllite, and we have some nice layers here. I'll show you examples in class. Now, another way that foliation can take place is having stripes. You'll notice these zebra stripes on this rock, but they aren't layers. When you look at this rock from this direction, they don't look like layers. You look at it from this direction, it looks like layers. So it's basically just striped, like the example that you see in the upper left-hand corner here. I'm going to show you a demonstration which will clarify that diagram in class. Now, the wavy layers will form perpendicular to the direction that the pressure is coming from. And here's a little, I guess I can't open that file, so another demonstration that I'll show you in class. Lastly, non-foliated metamorphic rocks. Here would be an example of that. We don't really see any clear layers. We see some crystals in there, but we don't see any layers that define it as a foliated texture. Now there's a third texture that comes about with metamorphic rocks, and that's called porphyroblastic. Now that word might sound a little bit familiar because we heard about porphyritic igneous rocks. And remember, porphyritic igneous rocks have very large crystals, coarse-grained crystals surrounded by very dull-looking fine-grained crystals. Well, in a porphyroblastic metamorphic rock, we have the similar type of look. We have a very large crystal surrounded by more fine-grained crystals around. And so this can happen under the very highest heats and highest pressures during certain types of metamorphism, which we'll get to in a moment. Here you can see a couple more examples. We have these really large crystals. These big chunks are called garnets. And then here we have another way that this rock can look as well. So they don't always form these nice big red crystals. Sometimes they can form other minerals as well. Now we get into the grades of metamorphism. Okay, combinations of heat and pressure can create different forms of metamorphic rocks. As you can imagine, the higher heat and pressure will cause a different type of metamorphic rock than low heat and pressure, and so this gets us into the grades of metamorphism. So a high-grade metamorphic rock is one that has changed a lot compared to the original rock. So the original rock that is applied heat and pressure has changed completely to become a high-grade metamorphic rock. Then we have a medium grade, somewhere in between, and then we have a low-grade metamorphic rock. Now a low-grade metamorphic rock has not changed much compared to the original rock. So I'm going to give you an example. This black-looking rock right here is shale. I'm not sure if you can see in the video, but it does have these nice layered appearance. So if you start squeezing it and applying heat and pressure from the layers of rock above, we can get this. This is called slate. Now you'll notice that the color is very similar, so we haven't had much reorganization of crystals or new crystals form. I'm not certain if you can see the layering that's going on here. And there's also the very faint signature of some layers on this surface. So the layers of this sedimentary rock are going left to right, and that's what we see the remnants of here. The layers that you see going on like this is because this rock, shale, has been squeezed so much that the layers that were once going left and right are now going up and down. And so that's why we have those layers of shale the way we do. So this would be a low-grade metamorphic rock. Again, it hasn't changed much compared to the original. Here is the original rock. Here we have a medium-grade metamorphic rock. You can see the color is slightly different, but it's still layered. And then finally, if you continue to heat it with a lot of heat and pressure, we can get this. Notice how crystalline and sparkly this is. That's because the very high heat that formed the metamorphic rock right here on the right was the highest heat and highest pressure. So you see that this has changed quite a bit from the original. Here we can see now the types of metamorphism. All right, what we have on the top left is the evidence of regional metamorphism, and regional metamorphism is caused when high pressure and temperatures are during mountain formation. So when two crustal plates squeeze together, you see that ridge in the center, okay, that would be the early formation of mountains, and the rock layers within get bent and twisted like you see these rock layers are bent and twisted there. So that would be regional metamorphism. On the right-hand side, we have what's called contact metamorphism. This black layer of rock was once magma that melted its way through cracks that existed between these rocks, and you can see this faint reddish orange area right in between the gray-looking rock and the black rock. This is contact metamorphism from the contact of the magma. And then finally we have hydrothermal metamorphism, and if you remember that picture I showed you before, the area of Yellowstone has a lot of that going on because of the hydrothermal effects from the superheated water. And that's pretty much it. That's a crash course on metamorphic rocks. Don't forget to have filled out those questions on the Google form and make sure to submit it and then mark it as done when you turn it in. Thanks, guys.